Right, so welcome to the second video for this week. In the first one then all I did was give a brief overview of the different positions, and now we're going to be going into more detail, looking at them, looking at objections to them, focusing on the A theory views as I've said, because the B theory view we'll be dealing with in more detail in later weeks. Really, we'll be dealing with it alongside other issues. So we're going to be focusing on the A theory. Now, the first view then I want to start off with is the moving spotlight view. And here's a picture of C.D. Broad, who I've mentioned him a few times. He was the one who wrote a great big long book on, in fact a 2-volume set on McTaggart's views, an examination of McTaggart's philosophy, sort of 1,000 pages long. So yeah, he was interested in McTaggart's arguments, and particularly his view on time. And it's him who comes up with the epithet, the moving spotlight view. Although he didn't hold the view, he defended the growing block view. Nonetheless, he attributed the moving spotlight view broadly to McTaggart, and he gives it its name. And we've seen what it is. It's the view according to which past, the present and the future all exist, and the present moment is privileged and moves in some sense along the timeline. Although I'll say something about the idea that it moves along the timeline in a minute. So, first of all, though, in favour of the view, Broad mentions these views, and I mentioned them briefly in the last video as well. It gives us an easy answer to the question, why does it seem to us that time flows? And this I didn't mention exactly, but it also does explain the ordinary belief that there is a genuine difference between the past and the future, or perhaps we can put this in terms of the direction of time. It explains why time flows in a particular direction, because it's the movement, the direction in which the movement occurs is from past to future. And we saw McTaggart mentions that. Last week we saw that McTaggart talks about that. Now, before I actually come on to the objections to this, I want to actually skip back to my board just briefly, because I want to just say, when we've got this moving spotlight view and the idea that, you know, there's a moment moving along the timeline, I've put it in those terms, you might think that you've got to literally have something moving here along the timeline in order to make sense of this view, that the present moment must somehow skip from one place to the next. But it's not quite right that we have to have this. So one way of illustrating the idea, and I think it's useful, is imagine that you've got, these are a series of light bulbs, okay? So the moving spotlight, by the way, you imagine shining a torch and then moving it along. That does seem to suggest that you've got this light moving, but I was thinking we don't necessarily have to have this. So these are a series of light bulbs with their, I don't know how to draw a light bulb, that's the wick. Do they have wicks? Oh, anyway, it doesn't matter. And what we could have is this. So suppose we've got the first light bulb is on, and then imagine it goes off, and the second light bulb comes on, and then it goes off, and the third light bulb comes on, it goes off, that one comes on, it goes off, that one comes on. And imagine a long row of these. What would it would look like if you put all those light bulbs out in front of you, that there's something moving across the light bulbs, you know? So one comes on, then goes off, and the next one, if it's timed right, comes on. It would look as if you've got a movement there. But of course, there isn't really any movement at all. All that's happening here is that one light bulb is gaining a property, so the property of being on, and then it loses that property, and the next light bulb in the series gains the property of being on, then it loses it, and then the third, right? There's no, it's not like the light that's in one jumps across and moves into the next. One goes off and the next one comes on. So we could think about it like that. We don't have to think about, and in fact I think that's the way that McTaggart would think about it. There's not literally something moving along the timeline. It's rather something like, as time flows, certain moments of time in the B series lose the property of being present and then the next moment along gains that property. So it's almost like you can think about it as the light bulb of the present coming on, right, and then going off and coming on at the next moment, and so on. So it's just to say, although it's called this moving spotlight, we don't actually have to think about there being anything that literally moves. I hope that makes some sense to you. All right. So okay, we've got a few things in favour of the moving spotlight view here, but let's look at some objections. So these, what we're going to do, in fact, we're going to look at the historical objections to the moving spotlight view, the ones that Broad himself raised, and we'll see that actually Broad rejects the moving spotlight view for a couple of reasons, and it kind of just disappeared. It went out of fashion. Nobody defended the moving spotlight view again, really, until about 4 years ago, 3 or 4 years ago. So there hasn't been that much discussion of the moving spotlight view since Broad. So it's rather odd, actually, because the objections that C.D. Broad gives to the moving spotlight view aren't that great. They're not really that convincing, I don't think. But philosophy, like anything else, tends to have its sorts of fads and fashions, and it just so happened that the moving spotlight view just fell out of fashion for a long while. It just wasn't considered. Philosophy is a very big area. People are working on all sorts of issues, and it just so happened that this was one of the moving spotlight view was one that just wasn't picked up again. But I'll just show you this. So moving spotlight Cameron. So it has recently been developed and defended by Ross Cameron, called the moving spotlight. So this is Ted Sider. Ted Sider, by the way, or Theodore Sider, is probably he's probably the most famous philosopher of time who's alive today. He's worth checking out. Theodore Sider. He defends a B theory view, but anyway, Theodore Sider, he's written a hell of a lot on the philosophy of time. I think he's also the highest paid philosopher in the world at the moment. I think that's right. At one time he definitely was. So he's a fairly big name. But okay, yeah, so Ross Cameron got this book, The Moving Spotlight. There it is on Amazon. I've got a copy of this. I'm not sure whether I can share it with you because it was sent to me by Cameron, but it's not. I think he said don't share it. So I'll have a look at the email and see what he said. But okay, 2015. So 5 years ago, this came out. So the point being, right from the time when C.D. Broad was writing, up until 2015, the moving spotlight view fell out of fashion. So there hasn't been that much discussion of it, and all we've really got are these two historical objections to the view. But I do think there is also some further objections to the view, or objections which apply to it, but we're not going to be looking at those in this video because they were actually applied to the growing block view. So the growing block view has been a much more popular position over the years, and we'll see that there are a couple of, one really kind of serious objection to the growing block view. That also applies to this moving spotlight view, but we'll look at it later. So, just to repeat and reiterate so that everyone knows what we're doing here. We're looking at the moving spotlight view. We're going to consider two historical objections due to C.D. Broad. Then, in the next video, we're going to turn to the growing block view and look at some more contemporary, recent objections to that view, but those objections will also apply to the moving spotlight view. Alright, so. Oh, and I should also say, it's not even clear that these historical views don't apply to the growing block view as well, but we'll come to that. So, okay, the first objection, then, to the growing block view, sorry, I'm getting confused, to the moving spotlight view, is the hypertime objection. And according to it, moving spotlighters, those who defend the moving spotlight view, must posit an infinite hierarchy of hypertimes hyper times, hyper times, and so on, in infinite hierarchy. Alright, why is this? Let's turn to the board again. Probably easiest to illustrate. Well, the thought here is, well, think about what the moving spotlight view says. I mean, one of the reasons why I can't draw, so if I try to draw on the board, on this drawing board, the view itself, I can't actually draw it, can I? What I have to do is, I have to draw these lines on here like this, and so I put in 2020 there, and I get my red colour, and I say, oh, look, here's where the present moment is. But if I want to show that present moment moving, what I have to do is I have to rub it out and then draw it in another place. In other words, I can't draw it in two places at once. I can't draw it here and here. That doesn't accurately represent the idea of the movement of the present. I can't just draw it there, right? It's because movement, if we're going to have something like movement or change in the timeline, we can't represent the change in a single drawing, because a single drawing requires, to show change, well, what is change? Change is being in one state at one time and being in another state at another time. And of course, this timeline here represents all times, right? And I can't draw something being in one state at this, the universe itself being in one state at this time, and another, right? It's like we need another timeline. Okay, let's see if I can make that even clearer. Not sure whether that made sense to you. Let's put in 1900 down there, and let's put in 2120 again, just to keep it. So here's the idea. Okay, I'm going to now draw, I'm going to call this hypertime. So it's another kind of a temporal dimension. And we're going to need this hypertime to represent the changes that go on in ordinary time. So if you like, this is meant to represent time, that line is. And the idea is, look, here's the point where 1900 was present. And then what happened is, it changed. So the whole of reality and time itself changed. It changed from 1900 being present, and then, let's just say, to 1901 being present. So now I can draw my red dot there, and you'll begin to see the idea. I'm not going to draw out all of these. Let's just draw a bunch of these. And then 19, it's going to be there, then it's going to be there, then it's going to be there. And here, so that will be 1902, 1903, 1904, and so on. So there I can represent, right, the movement of the present along the timeline. But what I have to do in order to do so, I have to draw hypertime. That is to say, if we get this change in which moment is present, it must be a change in a second order time, a hypertime, right? Otherwise, you got the idea. I hope that makes some sort of sense. So that means that if you're a moving spotlight view, it looks like you're going to have to admit the existence of a hypertime. That is, a time with respect to which the changes in ordinary time take place, the change in where the current present moment is. Yeah, and that kind of thought then leads into the idea, well, if we're going to have changes in hypertimes, then we're going to need a second order hypertime, so a hypertime, and then we're going to, right, because what we've got going on here is a change in first order time, so then we need to invoke hypertime. But then if we invoke a hypertime, we're going to have changes going on in hypertime, so we're going to have a hypertime, and you got the idea. I think this second step where we get to the infinite hierarchy, I don't think it works, to be honest, and I'll say a bit more about that in a minute. So I think this first idea that we need to invoke hypertime certainly seems right, but I'm not sure about the idea that we then need to invoke a further one. We'll come to that in a minute. So okay, that's the hypertime objection due to CD Broad. So responses. So the first one I want to say, well, let's suppose first of all that it does work, this idea that we're going to need an infinite hierarchy of hypertimes, 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 and so on. Now, the thought here is, well, sometimes, you hear of this infinite regress, and infinite regress is often thought to be a bad thing. But my initial thought here is, well, what's so bad about an infinite hierarchy of hypertimes? And indeed, there's an analogy here with Platonism, so Plato's metaphysical view. And maybe, I'm going to turn to the board again to try to explain these. So let's clear this off. So let's just draw out the analogy first of all, so you understand the idea. According to Plato, then, things have their properties. So let's just have this is in the world, and it's a red box. Things have their properties in virtue of bearing a resemblance to a form. So then we have, this is the form of the red. Okay, so the idea is meant to be, how has this thing got its property? Well, because it represents the form of the red up in the Platonic heaven, or participates in the form, however you want to put it. Okay, and then the idea is that, well, hang on a minute, so that's to say this is red, or this is red. That gets its meaning in virtue of the existence of the archetypal red thing, but then we can say this is a universal, right? So these are called often called universals. But okay, look, they call it a universal, call it a property. This is a perfect property. It doesn't matter what we put in there. So this thing has got a property of being a universal. Well, how does it get that? Well, perhaps it participates in a further form of being a universal. Not sure how to draw that. Just draw a kind of a circle. But then this thing has got the property of being a first order universal. So you're going to have to posit another one. And I hope you see that you get this kind of hierarchy. So if you want to explain one thing having a property in terms of the existence of another thing, well, if that thing has got its own properties, which it will have, then it looks like you're going to have to posit the existence of yet a further thing to explain how it has its properties, and then that thing will have its own properties, and you're going to have to posit a further thing itself, and so on. And the thought here is, well, okay, so what? Maybe the universe does have this kind of infinite structure. What's wrong with an infinite structure? You need to point out, you can't just say, oh, there's an infinite structure. It may very well be, for example, that there's no smallest thing in reality. So, we spoke about this, maybe you can divide physical things up forever and ever and ever into smaller and smaller bits. So, you get a table, you can divide it into a half table, a quarter table, and so on, until you get down to the molecule. You can cut that up until you get down to an atom, and you can cut that up into two halves, and then however it might be. Of course, that might not be true, and current physicists think that there are sort of the smallest bits, but it certainly wasn't obvious, and it's not obvious that that is right. It might turn out to be that things are infinitely divisible, so you can keep dividing things up, but that's no objection. That's just the way things are, if that's true. Right? It just could be that the world is infinitely divisible. You wouldn't say, well, you have to posit ever smaller, infinitely many smaller things. Yeah, well, okay, but that's just the way things are. And I think the Platonist can take the same line. They can say, yeah, sure, there's an infinite hierarchy of universals. Every universal has its property in terms of one that's higher than it, higher order than it. So, in a similar vein, it seems to me that the moving spotlighter could just say, all right, yeah, they're infinite hierarchy of hypertimes. It's just the way things are. So it's not clear to me that it's a knockdown objection. Oh yeah, and I mentioned this idea of quantitative and qualitative parsimony. So you do get, okay, let's put these up. I'll try and explain what this is about. So quantitative so it's to do with the principle known, this is to do with the principle known as Occam's razor. So William of Occam a he's a philosopher in the Middle Ages, came up with a principle which says do not multiply entities, that is, objects or things, beyond necessity. And this has really been taken up as a methodological principle. It means that basically, if you've got two theories which are otherwise as good as each other, the better theory is the one that posits the fewer number of things. So a very simple example here would be something like this. So bear with, we're going on a slight tangent at the moment, but I'll work it back around to what we were talking about. So just go with this, and I'll come back to what we were talking about shortly. So a very simple example would be, when we drop things, we notice that they accelerate towards the Earth at 9.8 meters per second per second. That's the acceleration under gravity. And what we do is we say, okay, so there's a force that holds between objects, and this was Newton's observation. We say there's a force called gravity, which pulls things together at a certain rate, right, 9.8 meters per second per second. Well, what we could have done instead of that, we could have had another theory that says, well, what's going on is we've got two forces, one called wavity and one called bavity, let's say. And wavity pulls things at 5 meters per second, and bavity pulls things at 4.8 meters per second, and they always operate together. Right? They never come apart. So that's what explains why things are pulled towards the Earth at 9.8 meters per second, these two forces that operate together. And it's like, well, yeah, okay. I mean, these two theories are going to be, so the theory of gravity, which pulls things at 9.8 meters per second, and the theory of wavity and bavity are completely equivalent. You can't tell them apart. I mean, they both do the same job. They both give you the same predictions, and so on and so forth. But it seems obvious, does it not, that this one is not to be entertained. There is an example where you are multiplying entities, in this case forces, beyond necessity. Why posit two forces when you only need one? There goes the idea. Okay, so that's Occam's razor in a kind of a nutshell. But there's supposed to be a difference between qualitative and quantitative parsimony. So quantitative parsimony, that's not very well written up there. How can I put it? Qualitative parsimony is, in fact, do not multiply types of entity beyond necessity. So, a theory which says that there are different types of properties might be bad. Well, one that says that there are 3 or 4 types of property. Another theory says there's one type of property. That one's better. But it's not meant to be worse, or it's not necessarily meant to be worse to multiply the numbers of things beyond necessity. I'm not really explaining this very well, am I? But okay, let me give an example to try and explain. For the example, I'm going to give David Lewis's account of possible worlds. And in fact, this is what Lewis says. So as you might remember, David Lewis believes that, so by the way, by actual world, remember we mean actual universe. So this is meant to be, WA is the actual universe. It contains all the things that actually exist. So, planets, people, chairs, tables. But it doesn't contain any unicorns. The actual world doesn't contain unicorns. But Lewis thinks that, right, there are other worlds out there. So here's another possible world. And in this world, let's suppose we've got unicorns existing, right? And there might be another possible world, W2. And in this possible world, we might, Santa Claus is real. Right, here's Santa. Oh dear. Anyway, there's Santa. And, anyway, it does. So, yeah, for Lewis, all of these different possible worlds exist, and they're equally as real as each other. When we talk about possibility, we're talking about the existence of things in other possible worlds. And look, you might think, well, blimey, this is really Occam's razor should tell against this view. We're multiplying. Look, I mean, how many different? We've got infinitely many different types of things. Lewis's response is, well, no, these aren't different types of thing. These are exactly the same type of thing as we've already got. So, you know, the things that exist in the actual world are all concrete objects. These things in other possible worlds are also concrete objects. So it's not more types of things, it's just more of the same stuff that we already have. So actually, my view is not qualitatively unparsimonious, it's only quantitatively unparsimonious, and that's not a bad thing. Really, the bad thing is qualitative, multiplying types of things. That's what Lewis says. It's not absolutely clear that that's a good argument, but it's got some merit, and the thought anyway is, if we think about the idea of hypertimes and then the infinite, so okay, we'll just draw this up. I'll just draw it quickly like this, and then hypertime here. So yeah, the idea was that we need to represent the moving spotlight, we need this second order of time. So this, if you like, is first order time, then this is second, and then you're going to need a further one. I don't know where I'll draw it here, perhaps. And then another one, and another one, and another one. And the idea here is, well, okay, it's only admitting more of the same thing, more hypertimes. So there's no qualitative bloat, only a quantitative bloat, and maybe that's not a bad thing. Anyway, this is all just to say I'm not entirely clear that it's really that bad, even if they have to admit this infinite hierarchy of hypertimes. But there's a second response to the hypertime objection, and it's simply that we don't need the infinite hierarchy at all. We can stop at the second level. So, yeah, all we need is time and hypertime. We don't need a hypertime. And this is, so Schlesinger, I mentioned this in the book, he makes this response. And, yeah, that seems right to me, in fact. So, actually I can leave this up, I think. It's like, okay, well, here we've got the idea that we've got time represented. So ordinary time, I'm drawing ordinary time in a number of different stages. So don't think that we've got multiple times here. This is ordinary time drawn in different states. And this is hypertime over here. Why do we need to go to another level? It's just not clear. I mean, unless you think that, you might say, perhaps we have to have a movement along hypertime or something. But maybe. But it's not clear to me that we can't just have time flows with respect to hypertime, and then we can talk about the flowing of hypertime with respect to ordinary time. As long as we've got two things that move relative to each other. Right, think again. So this is when I was talking earlier about the boat moving through the river, or the river flowing past the boat. Those two metaphors for the flow of time. Well, what have you got there? You've got two things. You've got the boat, you've got the river, and they move relative to each other. So, in both cases, in the first case we're keeping the boat fixed and imagine the river moving. In the second case we're keeping the river fixed and imagine the boat moving. But basically we've just got two things moving relative to each other, and that gives us the idea of a flow, right? Anytime you've just got two axes shifting relative to each other, then you've got some sort of flow or movement, or can think about it in that sense. So, what have we got here? Well, we've got ordinary time, we've got hypertime, and they can be thought about as moving relative to each other. It's enough to give us a flow, in other words. So yes, I think that we're not necessarily pushed to an infinite hierarchy of hypertimes. I think Schlesinger's right about this. And it seems to me, at any rate, that if we say that, then, well, what's wrong with that? What's wrong with the idea of there being a hypertime? Maybe you don't like it, but it's open, at least for the moving spotlight view, to say, yeah, that's the way things are. The flow of time is because there's time and hypertime, and that's just it. That's reality. All right, so there we've got an objection and some responses. I'm not sure what you think about the responses. Maybe you don't like it. But what I wanted to kind of point out, I suppose, here as well, one last thought is, I think that the idea that McTaggart has of the contradictory nature of the A series is because he doesn't consider, if you try to represent the movement of time but without positing a hypertime, then you get stuck in something like McTaggart's paradox. Because you want to say that the present moment is moving, but you've got no second, or you have to put the present moment. Yeah, maybe we'll talk about it in the seminar. So we'll come back to this issue in the seminar. But I think you can get from this what McTaggart's on about. All right, so let's move to the second of the historical objections. So there's the first. Oh, well, I'll tell you what. Before I get to it, I'm even going to say this. I'll do it now. I was going to do it in the next video, but why not do it now? No, I won't. I'll leave it till the next video. Okay, sorry. Let's move on to the next one. Next objection. The rate objection, then. Here we think about the idea of, well, if anything moves or flows or changes, then you've got to have a rate of change, or a rate of the movement, a speed or a velocity. So yeah, we can think about, if you say a car is moving, you can ask, well, how fast is it moving? If you say that something has changed, or is changing, times they are changing, well, how fast are the changes happening? We can ask that. So stick to movement. So if time is really supposed to flow, then we can ask, how fast does time flow? And C.D. Broad thinks that doesn't have any kind of a sensible answer. How fast does time flow? Well, we can't ask about that, because normally when we ask about how fast something is moving, well, we're asking, so how fast a car is moving is to do with, we measure that change in terms of time. So we say it's moving at 50 miles per hour. What we mean is, during the period of 1 hour, it will have moved a distance of 50 miles. But if we ask how fast time flows, what are we talking about? How can we have time changing with respect to time? Okay, there's the objection. I think there are some perfectly good responses to this as well. So this is Marcosian, Ned Marcosian, and he gives this response. Well, actually, he gives the second response. One response that we can give is just to appeal to hypertime, by the way. So before we get to the second response, we can just say, well, okay, when we're talking about how fast time flows, we're talking about how fast it flows with regards to hypertime. So, the question is, how fast does 1 unit of time, ordinary time, change during 1 unit of hypertime, or something like that? You still might not be quite clear about what answer we give to it, but at least we've got these 2 dimensions. So normal movement is displacement of space over time, and this will be displacement of time over hypertime now, if we appeal to hypertimes. But at any rate, whether or not we have to appeal to hypertimes, and even if we do, well, Marcosian, for example, says, well, what's wrong with this? Trivial answer. Yeah, it's true that if we're measuring the change in time, we're going to have to measure the change in time in terms of time itself, whether that be ordinary time or hypertime. But what's wrong with this answer? 1 unit of time per unit of time. So how fast does time flow? Well, it flows at a rate of 1 second per second, or 1 hour per hour, or 1 year per year, and so on. So Marcosian gives, other people give this answer as well. But so what's wrong with that? How fast does time flow? Well, it flows a second, something like that. Seems like a perfectly good response to me. So again, I'm not really sure that this the rate objection really is a good one. But before I finish, so this is Erik Olson, who's quite a good philosopher, by the way. He works on personal identity. He's what's called an animalist. He thinks that persons are identical with their bodies, so he denies a psychological account of persons. But anyway, he's quite a good philosopher. But he does make this terrible rejoinder, and it surfaced a few times. Otherwise, good philosophers. So I mean, maybe there's something more to this, but I can't see it myself. And the objection is, or the rejoinder to that response, the idea that we can say that time flows at 1 second per second, or 1 minute per minute, or something like that, goes like this. If time passes, then time must pass at a rate of 1 unit per 1 unit, e.g. 1 second per 1 per second. That's to take on Marcosian's suggestion about how fast time flows. But they say, but there is no rate of 1 second per 1 second. It's rather just a number. Okay. Therefore, no literal movement is involved in the passage of time. And it's like, well, okay, fair enough, but I don't understand this second premise. It's not a rate, just a number. And the idea seems to be something like this. The idea seems to be that, okay, if we say that things are moving at, 1 second per second, then we can write that as 1 over 1. So 1, right? And then the thought is, well, look, it's a division, so that just equals 1. And 1 isn't a rate, 1 is just a number. Something like this, I think. I mean, I don't really understand what the thought is here. And because, I mean, for one thing, well, when you write 1 second per second, this isn't a fraction. This isn't 1 over 1. We represent it. So think about, we say that a car is travelling at 30 miles per hour, right? We can write it as like that, 30 miles in 1 hour. We can certainly write it like that. That's what this represents, miles per hour. But we can't divide the miles by... So what is 30 miles divided by 1 hour? You can't divide these things. They're not. You can divide numbers, but these aren't numbers. This is 30 miles. These are miles, and this is an hour. You can't divide miles by hours. It doesn't make sense. Well, likewise, 1 second per second is 1 second over 1 second. And okay, they're both seconds, but just because they're both seconds, you can't divide seconds by seconds. It doesn't make any sense. It's like trying to divide a table by a table. What does that even mean? So anyway, I mean, this is all just to say, I mean, it's not only my response to this. You can find this response, the idea that this is just, premise 2 here is just a load of nonsense and doesn't really make any sense. You can find that response given by a number of people in the literature, Harold Noonan, for example. You have a look in the book. There's references to all of this in the book. So, okay, that's it then. We're going to finish. So this was meant to be... So we've looked at the moving spotlight view. Things to remember from this. The moving spotlight view, you don't actually have to think of anything moving. It can be like the light bulbs turning on and off, the properties changing, and that seems to be in line with what McTaggart thought. Then we've looked at a couple of historical objections to the moving spotlight view due to C.D. Broad. So we've looked at the hypertime objection and the rate objection, neither of which do I think are particularly convincing. But okay, because the view fell out of favour, those are really the only two objections that have been levelled against it. We're going to move to the growing block view now, look at that view, and we're going to consider some more recent objections that have been made to the growing block view. But actually I think they also apply to the moving spotlight view as well. So if you like, although we're moving on to the growing block view, we are going to be considering objections which apply to the moving spotlight view. Okay, thanks.